Have you ever stopped to think about what keeps your entire digital life safe? I mean, really think about it. Well, today we're going to pull back the curtain on this amazing invisible shield that protects your messages, your money, pretty much your whole identity online. We're talking about cryptography.
So let's start with a really basic question. How do you send a private message to a friend? It sounds simple, but think about it. The internet is basically a massive, crowded room. So how do you whisper a secret when you have to shout it across that room for everyone to hear?
Because that's the reality of it. The internet is a public square. When you send an email or a text, that information doesn't just go straight from you to your friend. No, it bounces between all these different servers and connection points, and at any one of those points, anyone could be watching.
Now, this challenge, this fundamental issue of keeping things private in a public space has a name. We can call it the secret message problem. And you know, for as long as people have had secrets, they've been trying to figure this out. But in our digital world, the solution is something called cryptography.
Okay, so here's the first big idea you need to get. Cryptography isn't about hiding the message itself. It's not like burying a treasure chest. Instead, it's about making the message totally unreadable to anyone except the person it's for. So even if someone does grab it, all they've got is a bunch of meaningless gibberish. It's kind of like a letter written in a secret language that only 2 people on the planet know. So here's how that whole journey works. It's a few simple steps. First, you've got your original message, what we call plain text. Easy enough, right? When you hit send, it goes through encryption. Think of this as putting it through a digital scrambler. What comes out the other side is ciphertext. That's the unreadable, garbled up version. Then, when it gets to your friend, their device uses decryption to unscramble it, turning it right back into the original plain text so they can read it. Simple as that.
All right, I know that might still sound a little abstract, a bit techy, so let's use a really simple analogy that's going to make this whole thing click for you.
Yeah, that's it. Just forget about computers for a second. All you need to picture is a regular old box, a lock, and a key. This one idea is going to unlock, no pun intended, the core of how cryptography works.
So in our little analogy here, encryption is just the act of taking your message, putting it inside that box, and snapping the lock shut. That locked box, that's the ciphertext. See, anyone can see the box. They can pass it around, they can look at it, but they can't get inside. Why? Because only one thing can open that lock. And that one thing is, of course, the key. Now, in the digital world, we're not talking about a piece of metal. The key is a secret piece of information, basically a long string of data. This key is the magic ingredient. It's what locks the box, and it's the only thing that can unlock it. It's the secret handshake that proves you're allowed to see what's inside. So look, this isn't just some clever idea for spy movies. This whole digital lock and key system is working for you, silently in the background of your life every single day. Think about it. Every time you send a message on WhatsApp or Signal, yep, that's cryptography. When you buy something online and type in your credit card number, cryptography is what's keeping that safe. It's what protects your saved passwords, and it's literally the S in HTTPS. You know that little padlock icon in your browser? That's cryptography telling you you're safe.
And honestly, I can't overstate this enough. Cryptography is the invisible shield that makes the entire modern internet possible. Without it, things like online banking, private conversations, e-commerce, they just couldn't exist safely. It's everything.
Okay, so right about now, there's usually a question that pops into people's minds. If all of our data is constantly being locked and unlocked and scrambled and unscrambled, shouldn't that slow everything down to a crawl? And that's a great question, right? We want our stuff to be super secure, but we also expect our apps and websites to be instant. So, is there a catch? Do we have to trade speed for security? Well, the answer is just brilliant design. For you, the person with the key, the whole process is engineered to be ridiculously fast. It's seamless. It happens in milliseconds, and you don't even notice it. But for an attacker, someone who doesn't have the key, it's designed to be the exact opposite. It's a brick wall. It's nearly impossible, something that would take massive amounts of computer power and time to break. Now, I want to be really clear about our goal here. The whole point of this explainer is to give you a really solid understanding of the idea behind cryptography, the what it is, and the why it's so important.
So we're definitely not going to get lost in the weeds. We're not going to talk about specific encryption algorithms with weird names like AS or RSA. We're not going to touch the incredibly complex math that makes it all work. And we're for sure not getting into deep security proofs. Today is all about the big picture, the core concept.
So let's bring this all home. Because what we've really been talking about this whole time, it's not just a clever bit of tech. What we've been building is the very foundation of all digital trust.
So what do you need to remember? It's simple. 1. Cryptography is what protects your digital information. 2. It works with that two-step dance: encryption to scramble, decryption to unscramble. 3. The whole thing hinges on a secret key to unlock the information. And 4. All of this together is the absolute bedrock of our online security.
And that leaves us with one last, pretty big question to think about. We've just seen how our entire digital world, our friendships, our finances, our identities, is all built on the trust that this cryptographic foundation gives us. So what happens to our world if that trust is ever broken?